This is the video notes for 9.3, Getting Schooled. It starts off with two students. Leo and Araceli are two students learning that statistics help people to analyze their world. In making more money, Leo and Araceli noticed a difference in men and women's salaries. Araceli thought that it was unfair that women were paid less than men. Leo thought that there must be some good reason for the discrepancy, so they decided to dig deeper into the Census Bureau's income data to see if they could understand more about these differences. First, they decided to compare the income of men and women who graduated from high school, or the equivalent, but who did not pursue further schooling. They created a scatter plot below, it's actually on the next page, with the x value of a point representing the average women's salary for some year, and the y value representing the average man's salary for the same year. For instance, in the year 2011, it represented on the graph by the point 17,887, 30,616. You can find this point on the graph in the bottom left corner. So let's look at that. So this is the point that they are talking about right here. So we're going to do a little analysis and answer a few questions about this graph that compares men's income to women's income who have graduated from high school, okay, but didn't get any more schooling, so just high school graduates. So let's see question number 1. Based upon the graph, estimate the correlation coefficient. So looking at it, it seems pretty spread out. So I'm going to say it's probably weak positive. So let's write that in. Weak positive. It's not completely scattered, so maybe we would say between 0.25 and 0.7. Okay, so that's our estimate for the correlation coefficient. Estimate the average income for men in this time period. Describe how you use the graph to find it. So we want an average income for men. So I'm kind of thinking we just need to kind of go in the middle of the data. So I'm going to think maybe something like here. Maybe this is kind of a nice middle, kind of a nice average. So I'm going to say about 34,000. About 34,000. How to describe how you use the graph to find it, and we're just going to say it was the middle of the line. What is the average income for women in this time period? So we're just going to see kind of middle of the line. I'm just going to go down right here. Let's say 18,750. So about 18,750, and it's kind of the same way that I got that number. It was just the middle of the line. Middle of the line, middle of the data, right? All right, let's move on to number 4. Leo and Araceli calculated the linear regression for these data to be y equals 2.189x minus 6,731.8. What does the slope of this regression line mean about the income of men compared to that of women? Use precise units and language. All right, so we're going to say m equals 2.189 means, now remember, a slope always is written as a fraction. This one isn't, but we can actually put a 1 underneath. And this is comparing the rise and the run, right? This is the rise. This is the run. The rise is the men's income, right? The rise is men's income. And the run is women's income. Okay, so that gives us a little bit more context for the 2.189 and the 1. So let's write a little sentence to flush it out. So we're going to say 2.189 in men's income for every $1 raise in women's income. Okay. So every time men's income goes up by $2.19, women's income goes up by 1. All right, so let's look a little further. Said Araceli. It's just as I suspected. The whole system is unfair to women. No, wait, said Leo. Let's look at incomes for men and women who have bachelor's degrees or more. Maybe it has something to do with the level of education. Leo and Araceli started with the data for men with bachelor's degrees or more. They found that the correlation coefficient for the average salary for men with bachelor's degrees was R equals negative 0.894. Predict what the graph might look like and draw it. Be sure to scale and label the axes and to put 12 points in your graph. All right, so down here, it's going to be years, right? And we're going from 2000 to 2011. So right here is 2000. I'm just going to label every fifth one. 1, 2, 3, 4, 5. So this is 2005. Here is 2010, and there's 2011. And then over here we have men's income with a bachelor's degree or more. So men's income with a bachelor's degree or more. All right, so I don't know the actual numbers for men's income there, but it says R is negative 0.894, so that's pretty lined up. So let me just add a whole bunch of data points, and they're going to be forming a pretty strong negative correlation, right? I'll put one more. Okay, so something like that. The actual scatter plot for salaries for men with bachelor's degrees from 2000 to 2000 is provided on the next page. How did you do? All right, I'm going to zoom out. How did we do? We did okay. Definitely lining up, some below, some above. All right. Number 6. Both Leo and Araceli were surprised at this graph. They calculated the regression line and got y equals negative 588x plus 69,978. What does this equation say about the income of men with bachelor's degrees from 2000 to 2011? Oh, how interesting. So I don't know if you remember the graph before problem 1, but that graph only went as high as 36,000 for men's income. It's saying here if they have a bachelor's degree in 2000, 2000, they would start at 69,000, almost 79,000. So that's actually a big jump from just having a high school degree to having a bachelor's degree. All right, let's go ahead and answer the question. What does this say about the income of men's? Okay, use both the slope and the y-intercept of the line of regression for your answer. Okay, the slope. I'm going to say the slope means that every year income went down by $588. Okay, and then let's do the y-intercept. The y-intercept means in 2000 they start at about 70,000, which is really good, right? At 69,978. All right. Next, they turn their attention to the data for women with bachelor's degrees or more from 2000 to 2011. Here are the data. Analyze the data for women with bachelor's degrees by creating a scatter plot, interpreting the correlation coefficient and the regression line. Remember when it says regression line, this is just the line of best fit, right? It's just another way of saying line of best fit. For consistency with the men's graph above, use 0 for the year 2000, 1 for the year 2001, etc. Draw the graph, report the results of your analysis. Okay, so we need to go to Desmos for this. In our Canvas course, if you go to the lesson resources for 9.3 Getting Schooled, you will actually see a base file called 9.3 Task 7 Desmos link that will help you with this task. So it has the data already in. All you'll need to do is add in the formula to find the line of best fit. So go to Canvas, grab that file, and then you should have it open. It looks like this, right? This is task 7. Here's the data for women with a bachelor's degree or more. I've already put in the table for you, and then all we need to do down here is put in the formula for the line of best fit, which is y1, and then you need the tilde, right, because it's a formula, mx1 plus b. Now, if you have not written this formula somewhere in your book, please do so. And remember that the y1 and the x1 are referencing the table, right? This is the x1, y1 table. If there were multiple tables in your file, right, in your Desmos file, then if I wanted to reference the second table, I would do y2 tilde mx2 plus b. If I had wanted to reference the third file, I would go, the third table, I would go y3 tilde mx3 plus b. Okay, so if you don't have that formula written somewhere in your book, please write it down. All right, so it looks like I've got my regression parameters, right? Those are the line of best fit. I have my line of best fit on the graph. Looks like the slope for women is negative like $82, and the y-intercept is $43,357, and the correlation coefficient is kind of weak. It's negative 0.40. So let's go ahead and record those things over here, and kind of draw a sketch of our graph as well. So I'm going to go y equals negative 82x plus 43,357. That's just from Desmos, those two values, and r equals negative 0.40. Remember, that is weak negative. That's how you would describe a correlation coefficient between 0 and negative 0.7. Okay, let's go ahead and do a sketch of